All right, everyone. So this is lesson 310, and this is all about systems of equations. And when we have systems of equations, we are going to be talking about two equations that we're going to be working with together. And we're going to be using those two equations. We're going to solve them graphically, and we are going to also solve them algebraically. And then we're going to be talking about application problems with them. So I want to start out by saying that this homework is going to be due on Monday. It is in the textbook, and there will also be a review section for chapter 3, and the review is going to be due on Wednesday. And just a reminder that next week on Monday, there is going to be a chapter 3 test. So it's really important that you let me know if you have any questions. All right, so let's start with the class section. So the class section is starting with, let's just review the problem solving strategy that we've discussed in lesson 2.5. We've also discussed it in other lessons as well. So the first thing you have to do is make sure you understand the problem. Then you have to come up with a plan, and then you have to carry out the plan, and then you have to check your solution. Okay, so we are going to start systems of equations with this example right here. And I start the example so that you know exactly where to start. And it says the shipping manager at a small business sent out a shipment of 3 coffee mugs and 6 promotional packets on Monday. And the total shipping weight was 42 ounces. On Wednesday, she sent 6 more mugs and 3 more packets. And this time the total weight was 48 ounces. Now the boss wants to know the shipping weight for each packet and for each mug. Our goal is to help the shipping manager out. Okay, so if you notice, I underlined all the important information, and on the next page, we're going to use that information to try and answer this question. So let's see. So in question 2, it says, in this problem, there are 2 variables, quantities that we don't know, the shipping weight of a packet and the shipping weight of a mug. We use X to represent the weight of a mug and Y to represent the weight of a packet. Write an expression that describes the combined weight of 3 mugs and 6 packets. So if you see here, it says X is equal to the shipping weight of mug, Y is equal to the shipping weight of a packet. So it says specifically they want to know an expression for the weight of 3 mugs and 6 packets. So 3 times X plus 6 times Y. And now question 3 says use our answer from question 2, so 3X plus 6Y, and write an equation that describes the weight of the first shipment. Well, if we go back up to the initial question, it says that it has a weight of 42 ounces, right? So if you look here, it says 3 mugs, 6 promotional packets have a weight of 42 ounces. So there is my expression for 3 mugs plus 6 packets is equal to 42. Now, we can also write an equation for the second set of information, and that is 6 mugs, 3 packets has a weight of 48 ounces. So that's where they got this equation right here from. 6 times the number of mugs plus 3 times the number of packets is equal to 48 ounces. Okay, so question 4 is going to ask us to solve each equation for Y. And before we actually get into the solve, I just want to talk about this. So first thing is we have 2 equations. And if you recognize, both equations have 2 variables. This first equation has an X and a Y, and the second equation has an X and a Y. Because there's 2 variables, you cannot solve each equation by itself. We have to solve these equations together. And in order to solve these equations together, we have to replace one variable into the other. Okay, so there's a couple different ways we're going to go about doing this, but the textbook's getting us into learning how to do it graphically first. And as we've learned in the previous sections, graphing when the equation's in slope-intercept form, y equals mx plus b, it makes it a lot easier to graph the problem, because by doing it that way, we have our starting point and we have our slope to make a next point. So when question 4 says solve each equation for y, that's because we're going to put them into y equals mx plus b form so that we can easily graph them. And if you look here, I wrote out the steps to remind you how to do this. This is what we did in section 3.3, which was the literal equations. So to solve both of these for y, I'm going to subtract the x's from both sides. And then just note, so here when I subtracted 3x from both sides, because I need to get this 3x over the other side, 42 and minus 3x are not like terms, okay? So because these are not like terms, they cannot combine together. And I don't know why I wrote this as a y. That should be an x right there. So that should say 42 minus 3x, not 3y. And then so then bring the 6y down, and then it says divide by the number in front of y. So I'm going to divide everything by 6. So I have 42 divided by 6 and 3 divided by 6, which 42 divided by 6 is 7, and 3 divided by 6 is a half. Okay? And then I'm going to do the same thing for this one. So I'm going to subtract 6x from both sides. So I'm left with 3y is equal to 48 minus 6x. And then I'm going to divide the whole thing by 3. So 48 divided by 3 is 16, and negative 6 divided by 3 is negative 2. Okay, and again, if you're struggling with this, take a look back at 3.3 on literal equations, and there's a bunch of extra practice in that section on Blackboard that you can work on those with. And then it says to make a table of values for each equation. So if you look, I wrote the equation here, and just note y equals 7 minus x over 2. That's the correct equation. That should be an x up there, just a reminder again. And then this one says y equals 16, take away 2x. And I'm plugging in these values of x for both equations. So if you look, so it's 7 minus, x is being replaced with 2, 2 divided by 2, and 2 divided by 2 is 1, so 7 minus 1 is 6. 7 minus 4 over 2, because x is 4, 4 divided by 2 is 2, so 7 minus 2 is 5. Then I'm going to do 7 minus x over 2, well, x is 6. 6 divided by 2 is 3, 7 minus 3 is 4, and so on until you complete this one. And then my second equation is 16 take away 2x. So I'm taking these values of x again, and I'm replacing them in for x. And when you simplify, you get these answers down here. Okay, so by putting them into y equals mx plus b form, then it makes it a lot easier to plug in and find your result for y. And just remind that these are points on a graph. So this would be the point 2, 6. This would be the point 4, 5. This would be the point 6, 4, 8, 3, and so on. And then I can make another set of points for over here. So this would be the point 2, 12, 4, 8, 6, 4, 8, 0, and 10, negative 4, and so on. Okay, so just keep in mind, because we're going to be making this graph in a little bit. All right, so now question 6 says graph both equations on the same grid and make sure you label which is which. So if you notice, I have, this is my first equation, y equals 7 minus x over 2. And there's a couple ways I could do it. I can use my table, so the points that we just spoke about here. So I have the point 2, 6, 4, 5, 6, 4, and I plotted those, right? Here's 0, 7, 2, 6, 4, 5, 6, 4, 8, 4, 10, 2, okay? And then I'm going to plot these are the points that were given to us on the second set of points. The other thing you can do to graph this is remember y equals mx plus b. My y-intercept is the 7 because the 7 does not have an x next to it. So that's my y-intercept. So it starts at 7 and it has a slope of negative 1 over 2. So from 7, I went down 1 over 2, down 1 over 2, and so on. Okay, so you can also graph it that way. Now, question 7 says, where does it look like the two lines intersect? We'll see this point, how they both share that point. That's the point where they intersect, and that's the point 6, 4. And question 8 is asking us to do a check. So if I were to take the point 6, 4, so remember, the x is the 6, and y is our 4, and I replaced x with 6 and y with 4 into both of these equations, you would notice that we get the same answer, right? We get the answer 4 equals 4. And that means that both equations are true, and that means that that is going to be the solution to the equations, because that is the point that satisfies both equations, which is the solution to the system. And that's how we solve a system of equation. So question 9 is asking us, what does the solution tell us about the shipping weights? Well, first thing is, we know x is 6. And if we go back, remember we labeled x was the weight of the mugs, and y was the weight of the packets. So it means each mug weighs 6 ounces, and each packet weighs 4 ounces. So that's the solution, and that gives us the answer of the problem. All right? So it says, how could you have found the solution of the system from the table you made without graphing? Well, if I go back up to this table, So you see right here at the when x is 6, we got the same answer out for y. If you notice that you're getting the same answer out inside the table, then that's a quick way of saying, well, this is going to be my solution. When x is 6, y is 4 is the solution. Okay. The other thing is we can use algebra. Okay, so I've highlighted here, starred, look at the table, but I also wrote that we can set both equations equal to each other and use algebra, and that's what we're going to be doing in a minute. Okay, so up until number 10, we solved these equations by looking at a graph and a table, and that's one perfectly good way of doing it, but just note that the algebraic approach might be a little bit faster. Okay, so it says our next goal is going to develop an algebraic model for solving the system of equations. So question number 11, write the result you got earlier when you solved the second equation for y. So we took, these are my two answers that we got up above, okay, and it was right in the beginning, maybe question 3 or 4. And I'm noticing that since both of these are set equal to y, they should be equal to the same thing, right? Because y equals, well, if they're both y equals, then they are exactly the same thing. So I took the 16 minus 2x here, and I'm going to say, well, that's equal to y. So 16 minus 2x can replace this y up in my first equation, which is where this equation came from. So 16 minus 2x, again, replaced the y over here. And notice when you do that, now I only have one variable in this equation. The only variable that's there is the x. And we're going to solve it for x. So I'm going to add 2x to both sides. And the reason why I'm adding 2x is because -2 is a smaller number than -1/2. Okay, you could go the other way, but then you'll have a negative, so just keep that in mind. So I'm left with 16 is equal to 7 plus 1.5x, because remember, a half is the same as 0.5. So 2 minus 0.5, because that's a -1/2. Now I need to solve for x. So I'm going to bring the 7 over to the other side so I can get x by itself. So I'm going to subtract 7 from both sides. 16 minus 7 is 9, equals 1.5x. Divide both sides by 1.5, and 9 divided by 1.5 is 6. And if you notice, that's the same answer that we got up above. Okay. So I already did number 12. I did that up here. I should have done it down here. But the one thing I didn't do is we need to also find our y. So you take either equation. It doesn't matter which one. I chose the second equation because I think it has easier numbers since we don't have a fraction. And I'm going to replace this x with the answer we got, 6. So it's y equals 16 minus 2 times 6, and you get y equals 4. And notice that you get the exact same solution that we got above. All right, so here are the directions for solving using the substitution method. If you forget how to do it, come look back, and we're going to go through a couple more problems. Okay, so first thing is, here's the did you get it. Please make sure you do this did you get it, because it's a very different type of problem than what we just did, and I think it's really important that you know how to do it. So the first thing is, when you're doing substitution, you do not have to solve both equations for y. Okay, you can just solve one of them. They don't both need to be done, because if you notice in this one, see how if I solved this one for y, because this y is by itself, I just had to add 4x to both sides. Now I can have y equals -6 plus 4x. Well, this can replace the y that's next to this 3 right here. So it gets 4x plus 3, and then this y is going to be replaced in parentheses with -6 plus 4x. So this right thing came right over here. And then we're going to solve using distributive property. So 4x comes down. 3 times -6 is -18. 3 times 4x is 12x equals -2. I combined like terms, so 4x and 12x made 16x. Take away 18 comes down, equals -2. Solve, add 18 to both sides. -2 plus 18 is 16, divided by 16 is 1. And then we have to find y, so I'm going to take my answer of 1 and plug it back into the original problem. 4 times 1 plus 3y equals -2. Solve that equation, and you get y equals -2, and we write our answer as a point. All right. So I'm going to post more of these kind of problems like this for mixed practice in Blackboard. Make sure that you try and do some of those. Also, Alex should have a bunch of those for you to work on as well. All right. Interestingly, this technique can also be used to solve problems that could be solved by writing a single equation, like the next one. So it says, while traveling on business, Eldrick brought a $50 prepaid international cell phone to call his girlfriend, Lindsay. Calls cost 7 cents per minute. How many minutes has he used if the display shows $32.15 remaining? So first thing, it says to answer this question, we could think about two different equations. One states that the value of the card is $32.15. Write that equation. Well, that's just the value is equal to $32.15. We know that it's not going to change. The value is always going to be $32.15. There's nothing changing, which is why there's no variable there. Now let's write the other equation that represents the amount that they paid. So $50 is where they started, right? That's how much he had, and it costs 7 cents per minute. So I'm going to subtract 7 cents, which is 0.07 times the number of minutes, is equal to the value. And they're going to do exactly what we did earlier with our two equations. Well, my first equation is V equals 32.15. Doesn't matter how many minutes you make, it's always going to be $32.15. And then the second equation, I'm going to replace X with 0, 100, 200, and so forth. And these are the numbers that you would get. And it asks us to put them on the grid. So I'm going to graph my first one. It starts at 50, and it's going down 7 cents every minute. So if you're going down 7 cents every 100 minutes, it's going to go down $7, which is why this point's here at 43. And then I'm going to go down another $7 and another $7 and so forth. Or you can plot these points that we found up here on the table. And this one's always a constant 32.15, which is why it's a horizontal line. And it asks us to use your graph to estimate the solution to the system. Well, the solution is right about here. It's right in the middle, about 250, maybe 32. At 32.15, and the reason we can be confident about 32.15 is because that's a horizontal line. How confident are you in your answer? It's probably not perfect, but it's pretty close because you can't see exact numbers in the middle here. Sorry, so this graphing is not perfect for this one because we can't see an exact answer, but algebraically would give us a perfect solution. So to solve this algebraically, I'm going to go back up to my two equations. V equals this, V equals this. Well, 32.15 can replace this V down here, which is where this equation came from, because both of these are V. I'm going to solve this equation for X, so I subtract 50 from both sides, and then I divided that answer by negative 0.07, and it gives us 255. So was it close? Yeah, because I estimated about 250. 255 is pretty close. How do you determine the second coordinate? Well, I'm going to take my answer of 255 and put it into the equation. So 50 minus 0.07 times 255, and that's going to give us an answer of 32.15. All right. So for the next Did You Get It, I just wrote out what your two equations were going to be. I didn't actually solve it, but the answers are in the back of the text after the prep skills section. So if you want to check your answer, I wrote the equations out to make sure you can get those and then go ahead and solve it. All right, so that's the end of the classwork section. I want you to try the group works on your own, and then once you finish the group work, check your answers to the next video to make sure you get it. And just remember, this homework is going to be due on Monday, and also there is going to be a test coming up the following Monday, so next Wednesday is going to be a review class. All right.